In this segment, we want to put it all together. We want to do some sketching of polynomials based on our leading term tests and what we know about zeros and multiplicities. Okay, so this first example, I've got a function, polynomial function that's in factored form for me, x minus 4 to the third, x plus 1 squared. Okay, very easy then to tell what my factors are. And once I know the factor, I ask, well, what would make that 0? A 4. What would make this one a 0? Negative 1. Okay, so those are our zeros. The multiplicity, remember, is just you look back up here. What was the exponent on the factor? 3. That's an odd number, and because it's odd, that tells me it's going to cross the x-axis there. Okay, for the other one, the exponent on the second factor is a 2. That's an even number, so I'm going to do a touch and turn when I come to the 0 of negative 1. Before I can get my sketch, though, I need to do a little bit more thinking. I need to think about that leading term. This is in factored form, so I have to kind of multiply it out, or at least partially multiply it out to see what the leading term would be. Because this is some quantity x minus 4 cubed, that would tell me that the first term when I multiply this out is going to be an x cubed. Over here it's stuff squared, so this is going to be an x squared. X cubed times x squared is going to give me x to the 5th. Okay, the leading term is positive, so that means the right side is going to be up, and the exponent is odd, so that means the ends are going to go opposite directions. Okay, so that means if I mark my 0 of negative 1, where we touch and turn, and my 0 of 4, where I'm going to cross, I know I'm going to have to start from the bottom. I'm going to come up, I'm going to hit the 0 at negative 1, turn around, then go back through. I'm not sure exactly where we're crossing the y-axis, and then I'm going to cross through and continue upward forever through the 4. Now if I wanted to have a little bit more accurate graph, I could of course find this y-intercept. This y-intercept is when x is 0, so you'd have to put zeros into your original function here and work it out. Alright, second example. Again, this is in factored form for me, and I have three things multiplied together here, right? X to the third, an x stuff with no exponent, and then an x minus 3 squared. So if I multiply this out, x cubed times x, that'd be x to the 4th. This is going to get me an x squared here at the end, so x to the 4th times x squared would be x to the 6th is our leading term. Positive, so that means my right side has to go up. Even exponent, so both sides are actually going to be up. All right, now let's take a look at the factors. We've got the x plus 2, and the x minus 3. Notice I didn't put any exponents on these. That's not really considered part of the factor. So if my factor is x, then the 0 is 0. That's the only thing you can plug in and get an answer of 0. The exponent up there was a 3. That's odd, so I'm going to cross. X plus 2 is my factor, means negative 2 is my 0. And up here, there's no exponent written. We assume then that means there's a 1 there. That's also an odd number, so we're going to cross at that spot as well. And the last factor of x minus 3 tells me my 0 would be 3. And I look up here, and this time we have an even exponent of 2, so we're going to touch and turn. So I know because of my leading term, I'm going to start from up here, and I'm going to have all my zeros labeled on there, the negative 2, the 0, and the 3. And I'm going to come through because I know I'm crossing at negative 2, and it says I'm going to cross at the 0, and then it says I'm going to come down, and I'm not going to cross at the 3. I'm going to touch and then turn around so that I end up going positive at the end.